Hello, welcome to our physics discussion, that is physics in a smart way. Now, the most essential jobs of ours, that is dealing with dealing with math, which are almost essential in physics, are almost over. Only a few tidbits are left out. I am considering a bit of that. As you know, so far as a curve is concerned, already we have discussed difference between a straight line and a curve is that a straight line has got a constant slope everywhere, but a curve has got a variable slope. If you try to find the slope of a curve at any position that you may like or your question may demand, let us say the position is here. Already this thing we have discussed. Then you consider 2 points on the left and right, or top and bottom, whatever you say, or in the close neighborhood of that curve, 2 points, and join them by a straight line. So thereby, what we are doing, you are drawing a tangent, and the angle that the tangent makes with x-axis is the slope angle, and tan of that slope angle is the slope of ours at that point of the curve. So you may take 2 points in the close neighborhood, join them by a scale, okay, with the help of a scale, or you may draw a tangent there, they got the same meaning. So, or as you know, a very small portion of the curve you are considering there, and very small portion of any curve that resembles a straight line. So angle that the straight line makes with positive x-axis is the slope angle, and that you know as the slope. So today we have got something to discuss in the context of that slope. And our topic will be maxima and minima. Maxima and minima. Okay, they are Latin words. In English, they translate as maximum value or minimum value, or maximum or minimum. But we need to clear up some space. Let us say we go for a curve which goes like this. And like this. Okay, you can see this point is the topmost point of the curve, that is point number 1. This curve, this point is the bottommost point of the curve. This point is a third point that gives you a value of y not high as this. But if you consider all the neighboring points, that is also having maximum value. And so far as the curve is concerned, if you write it mathematically, then y will be a function of x. Obeying that function, just like you know, straight lines, curves, conic sections, and all that. Any curve has got a controlling equation, any geometric curve. Of course, if you just draw a curve arbitrarily, that may not have any mathematics which is controlling it. So we are talking of geometric curves which are mathematically controlled. So this curve, we assume it's a mathematical curve, and we try to think of the slope at different points. If I take this point, which is the topmost point, you consider the point just to the left of the this, you consider the point just to the right of the this. If you take 2 points and draw a straight line, or maybe you draw a tangent, you know, because the point 1 is the topmost point, top of the hill, like where the y value is maximum. If you consider the other points which are in the neighborhood of that, so that is a point where the curve is reaching its maxima. And if you draw a tangent, you know, because the curve at the maximum value goes up and then starts to drop, if you consider a small point of the curve and draw a tangent or join the 2 points and draw a straight line, that always becomes a line which is parallel to x-axis, or you may say horizontal roughly. If the line is parallel to x-axis, you know how much angle that makes with x-axis. You know that angle obviously will be 0. Okay, if that angle is 0, then you know if somebody tries to find out tan of that angle will be obviously 0 because theta is 0, tan theta is 0. We know tan theta is slope, and slope is written, you know very well, with a symbol m, and that also can be expressed in the way of differentiation as dy by dx. Already we have discussed it. So at this point, we know because that is tan theta, always the value of the slope, and at this point it will be 0. So thereby, people say, or mathematics says, that at the highest or maximum value, derivative of the or the slope of the curve is 0, or derivative of this function dy by dx must be equal to 0. And that happens when the curve reaches out its maximum value. As you can see, the same thing also happens if the curve descends to its minimum value. If you take, when the curve descends, that dips down, dips down, dips down, and again rises. If you take a small portion of the curve or draw a tangent there, again that creates a line which is parallel to x-axis. Again that makes an angle 0 with the x-axis. So tan theta is 0. So we can say at maximum or minimum, value of a function, we are writing mathematically. Okay, we forget the curve, temporarily, of the function, its derivative will be 0, or the differentiation will be 0. That is of serious implication or serious importance in our physical sciences, that you have to remember. At maxima or at minima, derivative of the function will be 0. Why? We have seen, we have gone through a geometrical presentation using geometry or using curve. We are seeing that. But one thing may come out. If, let us say, my job is to study all the possible value of y, all the possible value of x, and correspondingly all the possible value of y from this to this, then you can clearly see at point 1 that the derivative, it is 0. So point 1 is having one of the maximum value. At point 2, that derivative is 0. That is having one of the minimum values. Again, at the point 3, that is getting a local maximum. We say that's a local maximum. Here also derivative will be 0. So now there may be a question, how can I know? Because at this point, if you take the function and make its differentiation to be 0, 3 points will be coming out. One is the point 1, second is point 2, and third is x or point 3. Okay, so now you'll be lost. Which point I am to consider as maximum, which point I have to consider at the minimum. Now my advice will be, do not go to all those details at present. You are starting to study, and it will be presented in your questions at present. In your questions will be presented such cases where you won't encounter 3 different things, 1 or 2 simultaneously. Because to determine whether one is maxima or minima, we require a further derivative test that is known as second derivative test. And I have not told you about anything, nor your teachers will be telling you readily now. So thereby, you'll be dealing with the portion of the curve, maybe from this to this. Okay, there we safely see one maximum, maybe from this to this, where we safely see one minimum, maybe from this to this, where we see only the point 3 is coming up, and in our equation study, we'll be getting point 3 comfortably. So if there are many different local maxima and minimas, you don't have to rake your brain on that. For that, you have to differentiate the equation once over again. That is known as double derivative or second derivative test. That is not of our immediate concern now. So thereby, we come back to our main topic. If the curve or if the function is achieving its maximum or minimum value, then at that point, its derivative will be dy by dx equal to 0. And talking geometrically, the slope, if you try to draw the curve, physically you want to see what type of curve or what type of line this function is creating. Okay, so thereby we know slope equal to 0 if somebody speaks geometrically. So that's all about maxima and minima. Any function, you can use it. Most of your functions that now we shall encounter will be coming in this category. Will be they can be dealt with very easily, and they can be easily managed to be solved. Okay, so let us consider an example in the support of our fact, because without example, maybe you will be slightly confused. So let we consider a question in the way that let y equal to minus 2x square minus 3x plus 5. Okay, find the value of x where y attains its maximum value. Its maximum value. Okay, so that is the question for us. And as you all know, that at maximum or minima, we'll be having derivative of the function is 0, or geometrically speaking, slope will be 0. So because we got the function y equal to minus 2x square minus 3x plus 5, we take its derivative dy by dx. So when you make it dy by dx, so that is derivative of, that is minus 2x square minus 3x plus 5 by dx. All the quantities present under the derivative sign, they seem to be separate from each other. So that will be minus 2x square will be giving us minus 2 into x, minus 3x will be giving us 3. Okay, 5 will be giving us 0. And you know, at maximum value, you have to equal with 2 0, because then only we can find the maximum value of x. So thereby we got that to be, so we equal to 0 because that was our idea. And that was the theorem that at derivative at maximum or minimum value derivative equal to 0. So that says minus 4x minus 3 will be equal to 0. So thereby, whatever, thereby we know that implies 4x equal to minus 3 or x equal to minus 3 by 4. Okay, x equal to minus 3 by 4. So when we put x equal to minus 3 by 4, the function will attain its maximum value. Yeah, and at that time y will be 49 by 8. You may check it or not, that is workshop, but already we have found out the value of x for which the function attains the maximum value or gets the maximum value. So that is one of the examples. Similarly, for minimum case, you do the same thing and ultimately equate the derivative equal to 0 and the job will be done. Okay, so that's all for today. Thank you for your kind viewership. So far as the use of math, application of math in physical sciences is concerned, I shall be stopping here. There are some other intelligent uses that we'll be learning later on. Okay, but at present, I got no plans to reveal it. You require some soundness, and initially you are just at the nascent state. Okay, how mathematics can be utilized to reduce the span of your solution, or how it can supply you with tricks and tips so that maybe using calculus, maybe using regular ways when you are required to solve it, and that too following at least 7 to 8 steps, how you can finish it off within one step. So those mathematics and all those things are there, but usually they are not present in our books in a systematic way. They are present everywhere, but we see a peculiar stupidity even if people dealing with physics, they do not try to teach the student in the intelligent ways or in the smart way, because our videos will be basically our the YouTube, क्या बोलते हैं इसको, YouTube, sorry, whatever you may say, channel, YouTube channel, I'm sorry, YouTube channel basically has got a name, has got a caption every time attached to it, physics in a smart way. So thereby later on, I plan to expose you to all those tricks and tips where you get to strengthen yourself, have a definite edge on your competitors, and solve the questions very, very quickly. Okay, those are known as tricks and tips, but mark it. Without theory, without concept, you cannot just take the help of tricks and tips. Those tricks and tips can be employed by the person who understands the physics thoroughly well. And for that, theory is the basic, essential. Theory is the basics. Do not ever try to fall into a trap. Some people might say, some teacher might say, maybe you are in a false impression. I just go to the formula, okay, and try to solve some problems. My job is over. Nowadays, I see people falling into a trap of the people who are about to appear at the engineering and medical entrances. They are going through so many tests. Sometimes tests are free, sometimes tests are paid, and some people, they do a good business out of that. But all those, so far as my idea goes, and my idea, okay, is on physics is more than 30 years old, that if we are not strong in the topic, then going for so many questions, test series and all those, that is completely futile, that is completely useless. Okay, I can give you my example. I didn't appear, I did appear in all those entrances way back in 1980 and 1981. Entrances were tough, they are not easy. They are never easy for anybody. You know, the moment they were introduced into our system, okay, I didn't appear, I didn't go for a single, the so-called test series and all that in our time, that was non-existent. Rather, I can find myself lucky, but I didn't fail in any of the so-called entrances that I did appear. Went to join an engineering college, went to you know, join some government organizations for job as an engineer, then left the job and came out to teach. That is the story of my life in short. But the thing is that the basic requirement that is that you must understand the topic thoroughly well. Otherwise, test and all those things, going for some questions, going for some quick answers and all those things, they are simply useless if understanding is not there. However, you know, okay, I did give a long speech. You must excuse me. So that's all for today. We'll be going for the 11th portion in my next videos. That will be starting with the study of vector and scalars. Thank you. If you find that is useful, you may like it, you may subscribe it, and you may share it amongst your friends. Thank you again.